example 6. In example 6, we're going to talk about how to use carbon dating in order to approximate the ages of different things. So in this example, we're going to pretend that we're finding the age of a dinosaur. So the formula is A equals A naught times 1/2 to the power of T divided by P, where P is the half-life. So carbon-14 has a half-life of 5,700 years. This is something that you're expected to know for the AP test. It's just like gravity is 9.8 meters per second. You're just expected to know that. And so in this example, we're going to determine the age of a sample where 10% of the radioactive nuclei originally present has decayed. So what I want to know is, could this radioactive nuclei come from a dinosaur? That's mainly what I care about. So we have our formula, which is A equals A naught times 1/2 to the power of T divided by 5,700. The 5,700 comes from the half-life, so this is equal to P. And so a side note is, if 10% has been decayed, we still have 90% of the original material left. So then using that information, we're going to get A is equal to 90% of A naught. So A is equal to 0.9 times A naught. And so now we're going to substitute that into our formula to figure out T. So we get 0.9 A naught is equal to A naught times 1/2 T divided by 5,700. So dividing by A naught on both sides, they both cancel. You get 0.9 is equal to 1/2 T divided by 5,700. And so we're going to take the ln of both sides. So you get ln of 0.9 is equal to ln of 1/2 T over 5,700. And then using our ln properties, the T divided by 5,700 is going to come into front. We're going to divide both sides by ln of 1/2 equals T over 5,700. And then we're going to multiply both sides by 5,700 to get T. So T is equal to 5,700 ln of 0.9 divided by ln of 1/2. And then all you have to do from there is put it in a calculator. So you get T is approximately 866.417 years. So this means that our sample is about 866 years old. Well, unfortunately that means it's not a dinosaur, because dinosaurs are not 866 years old. Alright, now this one I want you to try on your own. It's from page 357, it's number 25. The decay equation for radon-222 gas is known to be Y equals Y naught e to the power of negative 0.18 T within T days. Keep in mind this has to do with days, not years. About how long will it take the amount of radon in a sealed sample of air to decay 90% of its original value? So go ahead, pause the video, and try this on your own. Alright, so let's work it out. We get Y equals Y naught e to the negative 0.18 T. That's the formula that was given in the problem. And we know that we have 90% left, so Y is equal to 0.9 of Y naught. So we get 0.9 Y naught is equal to Y naught e to the negative 0.18 T. So we're going to cancel off the Y naughts from both sides. And we get 0.9 is equal to e to the negative 0.18 T. Then we're going to take the ln of both sides to get that exponent down, which is ln of e negative 0.18 T. ln of e is just 1, so that cancels off. And we get ln of 0.9 is equal to negative 0.18 T. So T is equal to ln of 0.9 divided by negative 0.18. So when you put that in your calculator, you get T is about 0.585 days. So it's very important that we have the correct units, because 0.5 days is very different than 0.5 years or 0.5 centuries.